This is a super fast changing space. I don't have to tell you that. It's very exciting. You know, Phil and I and a few colleagues have been running for longer than I care to recount, a small consulting firm focused on embedded processing, digital signal processing, video. And around 2010, 2011, we started to get some computer vision projects, and that got us thinking about computer vision and realizing that processors, embedded processors, were approaching the point where it would soon become feasible to put computer vision into all kinds of systems and applications, not just like the back of the Stanley self-driving car where you have racks of GPUs consuming thousands of watts. And that got us very excited about the potential for computer vision. And so we decided to start this industry group, the Embedded Vision Alliance. That's now grown. There are about 100 companies that are corporate members that help underwrite the operation of the alliance, and tens of thousands of developers of various kinds and other professionals working in industry who are connected with the alliance in some way, subscribe to our newsletters, visit our website, come to our Embedded Vision Summit conference or whatnot. And we decided it would be great to tap into that community to get some real data on what kinds of technology choices people are making and what kinds of challenges they're facing. Because this is such a fast-moving space, and it's hard to sometimes get a sense of, you know, what's just buzz and what's really getting traction. So that's why we undertook this survey. We've been doing it now for 3 or 4 years. It's an annual thing, and we could cover maybe 25 or 30 questions in the survey. I'm just going to hit maybe 10 here that I think are particularly interesting and relevant to developers. And well, see what you think. So one important note is lots of different people respond to this survey in different roles. Some are students, researchers, some might work for technology supplier companies like semiconductor companies. We're particularly interested in what people are doing in the system space. People are developing system level products. And so we focus most of our attention on the answers from those people working in industry on system level products. And this time around we got 345 such people responding. So the data I'm going to show you here represents just that slice of the respondents. You'll notice in many of the charts there will be arrows like this pointing up and down with percentages next to them. Those indicate changes from the prior year's survey to the current year's survey in terms of percentage points. So if, for example, last year, a year ago, 15% of people liked strawberry milkshakes best, and this year's 20%, then you'll see an up arrow with 5% next to it. That's what that means. We don't always have the up and down arrows because some of the questions are new in this version of the survey, or in some cases we modified questions in ways that make it not so apples to compare this year's results to last year's results. Also, you'll notice when we get into bar charts, in a lot of the bar charts, the bars add up to much more than 100%. And that's because in many of the questions, it's valid for respondents to give multiple answers. For example, if we ask, what kinds of processors do you use? CPUs, GPUs, FPGAs, etc. In many cases, people will give multiple answers because they use multiple types of processors. So don't be alarmed if you see bar charts where bars add up to more than 100%. So this chart just kind of establishes what I said a minute ago, that we're talking to people who are using or planning to use computer vision in products. You can see that 74% of this group of respondents is using computer vision, 19% planning to use. The 74% who are using, that's up from 71% a year ago. The 19% is down from 20% a year ago. So in aggregate, virtually all of the respondents are either using or planning to use computer vision in products. I'm a processor guy, and so the first thing I'm interested in is what kinds of processors are people using. And at this level of the survey, we're just asking about classes of processors, not individual suppliers, individual models of processor. Are you using CPU? Are you using a GPU, a DSP, a dedicated deep neural network accelerator or something else. And you can see here that CPUs are the #1 category. This should come as no surprise because, of course, in many systems, just like Bing from MediaTek was explaining a minute ago, CPU is kind of the default hub, and then there are accelerators, co-processors that are supporting it. So there's usually a CPU plus other things around it. So the typical response to this question would be, yes, I use a CPU and I use something else, a GPU, an FPGA, or some other kind of accelerator or co-processor, or maybe multiple accelerators or co-processors. No huge changes, as you see with the arrows from a year ago, the biggest one being a downtick in the FPGA category from 40% a year ago to 36% this year. And when I say this year, this data was collected in October, in November last year, and analyzed in the last couple of months. So I think this is less of a mystery now, but up until fairly recently, a lot of people were wondering and not sure, like, this neural network stuff, is this just a passing fad, or is this the real deal? Are people really using this in their products? I think it's very clear now that it's the latter. People are really using it in their products. And this data supports that. This is, again, product developers working in industry at the system level. And we ask, are you using neural networks in your products to perform visual understanding tasks? We can see that 40% say yes extensively, up from 35% the prior year. 19% say yes in a minor role, up from 16% the prior year. So add those two up, it's 59%, up from 51% a year ago. So I think it's pretty strong evidence that, yeah, this neural network stuff is real, not just a passing fad. We're not asking people, are you experimenting with this? Are you evaluating it? We're asking, are you using it in your products? And this is pretty remarkable to think that almost 60% of this group of developers are using deep neural networks in their products. Because if you think about it, just a few years ago, 4 years ago, 5 years ago, that number would have been approximately 0. So from 0 to 60% in 4 years or something like that, it's pretty amazing. Next question is, when you're creating those deep neural network algorithms, what software framework are you using, or frameworks are you using? And here the most notable result is that TensorFlow has really grown to dominate the field over the last couple of years. 3 years ago, Caffe was by far the most popular in this community that we survey, but now that's been displaced by TensorFlow. You can see Caffe was down from 58% a year ago to 38% this year. TensorFlow up by almost exactly the same amount to 84%, which is pretty remarkable considering how many of these frameworks are available. Now, that previous question, that was about developing the algorithms, evaluating, training, designing the deep neural networks. This question is about deploying the neural network. So once you've got the neural network functioning as you wish, then you want to deploy it in some kind of target processor. What tools, frameworks, libraries do you use for that? And here you can see that TensorFlow is also the #1 answer, but it's not quite as dominant for deployment as it is for what I'll call design. And I've circled here OpenCV. This one came as a little bit of a surprise to me because, as Satya said in his talk, OpenCV isn't generally associated with deep neural networks. It's generally associated with conventional hand-designed computer vision algorithms. But what we see here is that OpenCV is second only to TensorFlow in its popularity in this group, among this group of developers, as a framework for deploying deep neural networks. And it's gaining popularity quite quickly from 30% a year ago to 41% this year. And this is a key part of why we've added OpenCV full-day training class on day 1 of the Embedded Vision Summit in May, as Phil mentioned in his intro remarks.
Taught by?
Oh, yes, taught by Satya Malik. Okay, so deep neural networks are super popular for among product developers, for visual understanding. But what about non-deep neural network algorithms. Are those being displaced? No. People are still using non-deep neural network algorithms extensively, as this result shows. So here we ask, are you using non-deep neural network algorithms for computer vision functions? 63% of the respondents say yes, we're using them extensively. That's down only 1 percentage point from the year before. 20% say yes, using them in a minor role. That's up 3% from a year before. So all told, 83% are using non-neural network algorithms for computer vision functions, and that's up a couple of percentage points from a year before. So clearly, although deep neural networks are extremely popular and gaining, non-deep neural network algorithms still have a strong role to play in most applications. What about programming languages? Programming languages specifically for non-deep neural network algorithms, because of course for deep neural network algorithms, people tend to use the framework like Caffe or TensorFlow. That sort of defines the programming language and environment. But if you're developing a non-neural network type of vision algorithm, what programming languages do you use? And here you see there's a pair of bars for each language. The top bar is for creating the algorithm, the same distinction I was making earlier with deep neural networks. The bottom bar is for implementing it on some sort of target processor. And you can see that those generally track together with a few notable exceptions. For example, MATLAB is fairly popular for creating algorithms, as you would expect, because that's what it's designed for. It's not so popular for deploying algorithms, which completely makes sense, because that's not really the primary purpose of MATLAB. C++ here, of course, is by far the most popular, so that really makes good sense. It supports the OpenCV decision to focus on C++ and not C. We also look at libraries and APIs, things like OpenCV, OpenVX, Halide, OpenGL for non-deep neural network tasks. And here, again, we see OpenCV really stands out. 89% of developers in this group use OpenCV, and that's unchanged from a year before. So obviously, OpenCV is extremely popular and remains extremely popular. Again, this is why we've prioritized OpenCV as a topic for our training and our conference. Finally, just a different kind of question. We ask people what they expect to see in their organization's investment in computer vision technology over the next year. Do they think it's going to go up, go down, stay the same, go up a little, go up a lot, etc.? And here what you see is that 61% of respondents expect to see a big increase in their company's investment in computer vision. 32% expect to see a small increase. So all told, 93% expect to see either a small or large increase. 7% no change. 0% expect to see a decrease, either small or large. So I think that's very encouraging for those of us who are enthusiastic about the potential for this technology. It seems like more and more companies are seeing things the same way and ramping up their investments in computer vision. So that's the data I wanted to share with you today. Phil already said a little bit about the Embedded Vision Alliance. This data on the number of member companies was a little out of date. I think we're up to 98 member companies now, growing fast. But the main thing I wanted to say here is that for product developers, the Embedded Vision Alliance is here to be a resource on practical technical education. As you know, there are a million different research journals where papers are published, and conferences like CVPR and NIPS where research is published, and those papers can be quite valuable in terms of understanding fundamental techniques, but they typically don't shed much light on how you actually implement things in products. That's where we try and pick up and fill the gap to help people understand what's practical. How do you take an algorithm, a sensor, integrate it into a system, make it work in a practical way. We do this through our website, through the Embedded Vision Summit Conference, webinars, newsletters, etc. If you're not already familiar, I would strongly encourage you to visit the Embedded Vision Alliance website, sign up for the newsletter, check out the Embedded Vision Summit Conference, which is coming up in May. As far as I know, it's the only conference anywhere which is focused on this topic of how to incorporate computer vision into real-world products, systems, and applications. The audience is very focused on this topic, and all of the presentations, there'll be about 100 presentations this year, all of the demos, training classes, workshops are all focused on how do we build practical computer vision systems, what's feasible, what isn't, what are the options, sensors, processors, algorithms, software tools, what are the trade-offs among those options, what are the proven techniques, and what are some of the important trends in the technology, in the applications, standards, and markets. So if you haven't checked it out, come to the website. We've got about a third of the conference program posted, and there's more coming up every week. There's also a short video there you can see to get a sense of what the conference is about. That's my presentation. Any questions?
I think we've got time for about one question. I've got a question, Jeff. What in the data that you went through, what was the most surprising result for you?
Yeah, that's a good question. I think that I hope I won't irritate Satya by saying this, but I was just surprised that OpenCV has staying power. I mean, we knew OpenCV was super popular, but I thought its popularity might be eroded a bit given just how popular TensorFlow in particular has become. I think I oversimplified things in my mind a little bit and thought, well, all these people using TensorFlow won't need OpenCV, but obviously it's really not that simple, and the data shows no, actually TensorFlow has become super popular at 0 to 80-something% in 2 or 3 years. Meanwhile, OpenCV remains just as popular as it was 2 or 3 years ago.
Cool, thank you. And you'll be around afterwards for pizza?
I sure will.
Excellent.
There better be pizza.
All right, thank you, Jeff.